Hi, good evening, students. I hope I'm audible and properly visible to you, right? Just give me the confirmation in the chat box if I'm audible and visible. Yeah, I hope I'm audible, visible, right? Thank you for the confirmation. So, guys, today we are going to continue with the chapter that circle that we have discussed in the previous session, right? Right. So, in the previous session, we have discussed some usual concept from the definition point of view and some theorems we have discussed, right? So I just continue from there from the last lecture, right? So before moving on to the next part of the session, let me just quickly recall what we have done earlier, right? So we have two important results here from the previous session. First one is angle subtended by an arc of a circle. So like you can see a circle we have with center O and a PQ is an arc, right? Just look at this PQ is an arc. And by this arc, we know the center angle, that's POQ, this one, and this angle at the circumference, that's PAQ, right? So what is the relation between them? That's PAQ, right? Sorry, POQ. That's not a PAQ, it's a POQ, which equals to 2 times angle PAQ, right? So that means suppose for the time being, suppose this is X, so this will be simply, we have a 2X, right? And one more relation, if you write in the some other form, that's a PAQ is equals to the half of angle POQ. That means if inverse, if I can see the angle at the circumference, right? This one is half of the angle at the circumference at the center, and angle at the center is double of the angle at the circumference. That is the concept, right? I hope it is clear to you, right? So this is the concept that we have discussed in the last session. And the second point that we have discussed, and one more important point I just need to recall, the angle direction is very important here. Let me clear this one, then I will let you know. The direction of angle, if it is downwards, it must be downwards. That is important, right? If it upwards, then it must be upward. That is the important point. Second concept that we have in the today's session, that angle subtended by the in the same segment of the same arc, right? Suppose we have a same arc that we have discussed in the previous one, that's PQ. The angle formed at the circle or at the circumference, that is this one, PCQ and PAQ, both angles are equal. Let's say this is XX. And if I talk about how many angles formed by the same arc in the same segment, they're infinite angle form, right? Just look at, we will form like this, right? So these all angles must be equal because they are in the same segment. So that means angle PCQ is equals to angle PAQ. Got it, this one? All right. So these are the angles on the same segment. Okay. So let's quickly solve few homework questions from the last session that we have. This is the first homework question. Okay. So we have a two circle with center O dash and O, right? So we have one of the circle is bigger and one of the circle is smaller in radius, right? So just look at the question. Both circle intersect at B and C points. These are the point and the intersecting point. We have to find the value of this X, right? So how to solve this question? Let me help you how to solve. So as we have discussed in the previous slide, that one angle at the center, right, just double of the angle at the circumference. So, and you can say in vice versa, angle at the circumference is equal to the half of the angle at the center, right? So you can see here angle ACB is equals to half of the angle AO dash B. So if we solve this one, and how means you have to write the region here, right? We means angle at the circumference, angle at the circumference is equal to the angle at center. It's equal to the half of the angle at center, right? Is equal to half of the angle at the center, right? That means that's 130. So that means it will be gives you 65. This is the ACB angle, that means this one. And it is given to you ACD is a straight line. That means this angle sum and this angle sum will be 180, right? So also we have angle ACB plus angle BCD, which equals to 180. Why? They are linear pair, right? They are linear pair. So ACB is your 65. BCD we have to find is equals to 180. So angle BCD is equals to 180 minus 65, which gives you 115. That means we got the angle, this one, that is 115, this angle. Okay. Okay, so we got the angles BCD is 115 in the circle with center O. Now we have to find this X. So mostly people will make the errors like this is the angle at the circumference. So this is just double of this, but actually not, right? What is the problem? As you can see by this arc, the center angle is this one. Yes or no? And this angle is the circumference. That means I just told you earlier, the direction of angle must be equal, right? If it were downwards, take it downwards, right? So that means that is the main errors people will do. So please keep in mind, that means here we can say angle BCD is equals to that yeah, double of two times of angle BCD is equal to reflex angle BOD. Am I right? Of course. So this 2 times of BCD is equal to reflex BOD, means I'm talking about this angle. Okay. So 2 into 115 is equal to reflex BOD. Reflex BOD. That means it's a 230 is equal to reflex BOD angle, right? First thing. Reflex angle BOD. Now we find this angle, okay? Because we know that angle at a point, sum of angle at a point is 360, right? So now angle BOD plus angle reflex BOD, right? It is 360. It is 360, right? So BOD we have to find, let's say this is given X and this is 230, which is equals to 360. So finally X is equal to is coming 130. So X is coming 130. That means the unknown value which is asked by the asked in the question, that is 130, nothing else, right? So I hope you understood this one. Is there any problem? Put down your question in the chat box. I will take your query after the session, right? So this is X value is 130. These are the two homework questions. This is the first one, and one more question is coming in the next part, right? Chalo, let's move on to the next question now. The second question in the screen now, this one you have, this is quite easy than the previous one. See, in triangle ABC, the angle B is given, angle C is given. We have to find angle D here, BDC, right? Means basically if we are able to find this angle, then we done almost, right? So what we will do in triangle ABC, angle A plus angles B plus angle C is equals to 180, right? Why? By angle sum property, by angle sum property. So we, whatever we know the value, just put down here. Angle A we have to find, B is 58, C is 32 is equals to 180. Okay. So angle A is plus this is 90 is equals to 180. That means angle A is coming 90 degree on simplification, right? Just transfer this, we got angle A is equal to 90 degree. That means option B is correct, right? So these are the two homework question which we have, which you got in the last class, right? Okay. Now let's move on in today's session. Basically, what we have in today's session. So these are the answers from the previous questions. So now we have in today's session, right? So what we have in today's session, basically what we are going to discuss. So in today's session, we are going to discuss a special type of quadrilateral, that is cyclic quadrilateral, right? So just look at this screen. So let's see, suppose our means BCCI wants to conduct a T20 World Cup, which are upcoming in the next year, right? Let's see. So he means BCCI prepared the stadium for the cricket matches, right? So means BCCI placed some floodlights in the ground, right? In the stadium, you can say. There is a difference in the ground and a stadium. I will let you know later on the session. Okay. Mostly people think that the stadium and ground are same, but the little bit they are different, right? I will let you know that part later part of the session. So you can see there will be 4 floodlights mentioned, right? There will be 4 floodlights, 1, 2, 3, 4. Not this one. There will be 4 floodlights are mentioned. Okay. So how they are related to mathematics? See, we will just look at the next screen. When we join these 4 floodlights, we get the quadrilateral. You can see the quadrilateral. And what is special in this quadrilateral? That is important. What is special? You can see all the vertices at the boundary of the circle. This type of quadrilateral called a cyclic quadrilateral. This is one property. Means all the vertices of a quadrilaterals are in the boundary of the circle, not outside, not inside. Okay, boundary only. And opposite angle sum will be 180. That is the relation. So we have to find, suppose we have to find B and A, we just use the same property that opposite angle sum will be 180. That means opposite angles are supplementary, right? Opposite angles are supplementary. So let's see here. Let me just give you the written format that how to write. And for this quadrilateral ABCD, A angle A plus angle C is equals to 180 and angle B plus angle D is equals to 180, right? So this is a property of cyclic quadrilateral, means opposite angle sum is 180. Okay, and one important thing as I told, means these vertices may not outside or may not inside. It must be on the boundary of the circle. Okay, that is the important part. All right, so now simply we can solve this question. Now we know that opposite angle sum is 180, so this is 70, so we get this is 110, and this is 110, so we get this is 70, right? Chalo guys, let's move on to next part of the session. That's we have a question now. Please take note this question, everyone. So we will solve this question now, right? So PQRS is a cyclic quadrilateral. Okay, that means PQRS is cyclic quadrilateral. That means opposite angle sum will be 180. Okay, so here PQRS is cyclic quadrilateral. It is given to us. This means angle P plus angle R is equals to 180 and angle Q plus angle S is equals to 180. Opposite angle sum will be 180. So let's use any one of them. Both you can also use, but I am using just only one of the condition. So see, first one, P angle R is given 110. So this is 180. So finally we got angle P is equals to 70 degree, right? P is your 70. So P got 70 angle. Now we have to find the angle P, this T, that means PTQ. So let's talk about in triangle PTQ. In triangle PTQ. In triangle PTQ, if we talk about by angle sum property, by angle sum property of triangle, which is angle P plus angle T plus angle Q is equals to 180. So angle P we just find here 70. T we have to find, let's put down T in complete name PTQ. T and PTQ both are same. That's only the writing pattern is different, right? And Q, we know that this is 60. Let's put down here is equals to 180. So 70 plus 60 will give you 130, right? So 130 and PTQ angle is the left part is equals to 180. So finally we got PTQ is equals to 50 degree. This is one of the solution. I'm not saying this is only the solution. This is one of the solution, right? Another solution I will let you know. And secondly, how to solve, as we know that this is 60, right? So this is 120. So by linear pair, you just find this is 60. Okay. Similarly, by linear pair, this you will get 70. So in a small triangle, you also use this, right? So STQ, actually we need to find PTQ. That's why I'm just taking the PTQ triangle. But this is the another way of solving this question. Okay. So very important thing, you have to keep the information complete. Like if you write in the proper way like this, you will get full marks in the examination. Suppose this question will be of 2 marks, right? So 1 marks till up to here you will get 1 marks, and 1 marks you will get up to here, right? Means both part are correct, then you will get 2 marks. Otherwise you will get only 1 marks. Suppose you will get solve means complete answer up to now here, means you will solve up to here only. For this question you will get only 1 marks only, nothing else. Okay. So I hope everything is clear, right? Is there any doubts to you guys? Okay, all right. So let's move on now. Next question. So this is actually the solution how to write in the examination. Just see TSR is given 60 up to here you will get 1 marks. Then after last you will get 1 marks. 50 means if you will solve like this. But not only like this, you will solve in the previous way. That's also you will get full marks. Okay, don't worry. Now, next question. We have a triangle. In an isosceles triangle ABC, AB is equal to AC. That means side is equal to given. That means two angles are also equal. Very important question. And a circle is passing through B and C intersect the side AB and AC at D and E respectively. That means this circle passes through D and E. Means this triangle passes through D and E. Okay. Now we have to prove that D parallel BC. So prove the lines are parallel. We know the concept that any of the angles belongs to corresponding angle, or interior alternate angles are equal, right? Then we can say that the lines are parallel. So basically our motto to simplify to solve this question that so any two corresponding angle are equal or any alternate angles are equal, right? Let's solve this one. So what we have given here, firstly, given here we have triangle ABC, HN, isosceles triangle, right? And you can see, just observe this quadrilateral BCED. This BCED is a cyclic quadrilateral. Am I right? Right. So BCED is cyclic, that because all the vertex in the boundary of the circle. What we have to prove? We have to prove DE is parallel to BC. Okay. Right. So let's start proof this one. Okay. So anybody, how to start this proof? Any idea you have? Definitely you have. So let me help out you how to solve this question, right? Okay. So as ABCED is cyclic quadrilateral. BCED is cyclic quadrilateral, right? Cyclic quadrilateral. That means angle BDE plus angle C. That means this angle and this angle sum is equals to 180. First equation. Okay, and angle B is equals to angle C because ABC is isosceles triangle, right? Okay. Now first equation mean BD plus C angle is 180 and angle B is equal to angle C is equals, both are equal given to you, right? Okay, and angle now angle ADE plus angle BDE is also 180. Why this is 180? They are linear pair, right? They are linear pair. Just look at, let me show by the different colors, you will easily identify this angle. I'm talking about this angle and this angle. Are they linear pair? Yes, they are linear pair, right? All right, so from the equation 1 and 2, this is equation 2, both RHS are equal, so we just make the left hand side equal. From equation 1 and 2, so you can see this part means angle BDE plus angle C is equals to angle ADE plus BDE, right? That means this angle will cancel out from the LHS and RHS. BDE is equals to BDE, they will cancel out. So what we have remaining now, angle C is equals to angle ADE. C and B are equal, so that means angle B is equals to angle ADE. Now, what is ADE? This is ADE and this is angle B. So they are equal. What type of angles are they? They are corresponding angle, right? And we know that corresponding angles are equal. Corresponding angles are equal. That means the lines are parallel. This means DE is parallel to BC. So this is the complete proof of this question, right? So this is the proper way of writing in the examination, like to write given, to prove a proof. If somewhere is construction required, we also mention the construction part, right? So please take note this one. Is there any doubt to anyone with respect to this question? All right. So now let's move on to the next question. Means let's see if the solution is given like this. So same as I have followed, like in triangle ABC, B is equal to C, you know, and in cyclic quadrilateral, BD plus C is equal to 180 opposite angles of cyclic quadrilateral. Also BD plus AD 180 linear pair, you know. So from second, third, first you will apply AD is equals to DBC because BD gets cancelled out simply. And they are corresponding angle, that means D is parallel to BC. Okay. Now it's time to poll question. Get ready for the poll question, everyone. The first question in your screen. In the given figure, ABD is equal to 70. Okay, this is given to 70 and ADB is 30. Okay, we have to find BCD. This we have to find. Okay, so how to solve this question? Anybody? Yeah, of course, you know that how to solve this question. Let me help you how to solve this question, right? Let's just look at in triangle ABD. Just look at in triangle ABD. So in triangle ABD, right? So by angle sum property. By angle sum property. Angle A plus angles B plus angles D is equals to 180. So we know that D and B. So let's find A. So B we have a 70 and D we have a 30. right, is equals to 180. So angle A plus 100 is equals to 180. That means angle A is equals to 180 minus 100. That means angle A is equals to 80. Okay, angle A is equals to 80, right? Now we have to find this BCD, and we know that this ABCD is cyclic quadrilateral, right? So what is the measurement of this one? Opposite angle sum will be 180, right? So because ABCD is cyclic, ABCD is cyclic, that means angle A plus angle C is equals to 180. That means just put down the value A, we get angle C is equals to 100 degree again. So how we got 100? 180 minus 80 will give you 100 degree. That means option A is correct. Right guys? So option A is correct. Please take a note this one. Then I will move on to the next question. All right, so I hope you have done. Let's come up with the next question now. This is also one more important question from cyclic quadrilateral point of view. Okay, just look at ABCD cyclage given to you, and BC produced to E, and CF is drawn parallel to AD. So you can see ABCD is cyclic, that is given. ABC is 120. So what is the measurement of this angle? Yes, it is 60, right? Why? Their sum will be 180. And one more important thing, ECF is given this small part of the triangle, that is given 20, right? We have to find BAD. BAD, that means we have to find this angle. Okay, this is our concern. So if anyhow we got this angle, then we done, right? But how to find that one? That is important, right? Okay, so just look at this is R60. Why? Because quadrilateral ABCD is cyclic, right? This means angle B plus angles D is equals to 180. So B is your 120 plus angles D is equals to 180. That means angles D is equals to 180 minus 120. That will gives you 60. Right? Angle D is equal to 60. Now we have also given this CF is parallel to AD. That means this line is parallel to this line. That means this angle and this angle. Let me change the color a little bit. I'm talking about this angle and this angle, right? Both are equal. Why they are equal? Because they are alternate interior angle. Yeah, interior alternate, right? So we have a angle CDA is equals to angle DCF. This is 60. Why? Interior alternate angle. Yes, because lines are parallel, so they are interior alternate angle. This one and this one. Okay, now we got this 60, this 20. And what is the measurement of angle DCAE? Now angle DCE is equal to 60 plus 20, means basically we had to add them. We got 80. Okay, we got 80. Finally, almost we are at the last step. Not last, it's the second last, you can say. So now we have this angle and this angle, which I'm just, let me just clear some part of the diagram. So as you know that this whole angle we got 80, right? Whole angle we got 80. That I'm talking about DCE. So now angle DCE plus angle DCB is equals to 180 just because of linear pair, right? This angle and this angle. So this is already we got 180 only, and DCE we just sorry. This DC is given, that's 180. This DC is your 80. DCB we have to find is equals to 180. So by solving this, we got DCB is equals to 100 degree, right? DCB is 100 degree. That means we got this angle is 100. This is 100 now. Now again we are using the cyclic coital property. Again, angle A plus angle C is equals to 180. Why? Because ABCD is cyclic quadrilateral, right? So C means angle DCB. C means angle DCB. So angle A plus 100 is equals to 180. So angle A is equals to 180 minus 100. It will gives you only 80. So I hope you understood how to find this angle A is equals to 80. That means option A is correct. Is there any problem to anyone? Is there any problem to anyone? All right. So please take note this one. Then we will move on to the next question, right? All right. So let's move on to the next question. So these are the answers from the first and second question that we have already discussed. Now this is the important part. Common doubts peoples we have. Just like other theorems we have seen, like in if you know that in midpoint theorem, right? So midpoint theorem, the two midpoints is given, then the line passes, so this midpoint is parallel to third side, right? And its converse is also true. Yes or no? Similarly, we have a, just like other theorems, does this theorem also have a converse part? Let us say that we are given a coital ABCD that A plus C is 180, B plus D is 180. Then can we say that anything about whether these points are cyclic or not? Yes, we can say that they are cyclic, right? We can say they're cyclic. Okay, so means its converse part is also correct. Means when the sum of any two quadrilateral is 180, right? So if I talk about rectangle and square, if you know that, right? If I talk about rectangle and square, so what is the sum of opposite angle? Rectangle and square, it's we know that sum of opposite angle is 180. I hope everyone know that, right? Because square all angles are 90, the opposite angle sum will be 180 as well as for rectangle. But anything else we have, they are not a cyclic, right? You can say simply. So rectangle and square are the only quadrilateral in coital point of view. If we talk about, these are only cyclic. So it means if we have these opposite angle sum is 180, then we can say that they are concyclic. Yeah, means these 4 points A, B, C, D are concyclic, yeah, cyclic quadrilateral form. So yes, in short, we can say that its converse part is also true. Okay. So is there any doubt to anyone till now? Anybody? All right. So now let's move on to the next question that we have. So you can see, as I told, if the sum of opposite angles of any coital is 180, then we can say that it is cyclic. Simply, it is cyclic, we can say. Okay. All right. So now let's take a note this question. This is quite important question. In the given figure, AC and BD are the diameters of a circle. This is very important. Means what is given to us? AC and BD are diameters of circle. Diameters of circle. Okay. We have to prove this is cyclic coital, means opposite angle sum. If we done 180, then we can say it is cyclic coital, right? So what we have to prove? We have to prove any part like angle A plus angle C is 180, or angle B plus angles D 180. Any part we have to prove, right? One we will prove, second we will directly write similarly. All right, so how to start this proof? As we know that, I hope everyone know from the previous fifth session that we have discussed angles on semicircle. As we know that angles on semicircle is right angle. Am I right? Of course, you know that we have discussed these things in the previous session, right? So when let's say, what are the semicircle? When AC is diameter, when AC is a diameter, right? When AC is diameter, what that mean? That means this angle, if AC is diameter, then we can say that this angle ABC is 90. Angle ABC is right angle, as well as angle D is also 90 because AC is diameter. That means ADC and ABC are the angles on a semicircle, right? And angle ADC is equals to 90 degree. That means now you can see ABC and ADC we got 90 and 90. So let's add them. So angle ABC plus angles ADC, both are opposite angles. So 90 plus 90, we get 180, right? That means we can say that it is cyclic coital. Similarly, we also prove that similarly angle C plus angles A is equals to 180. How we will prove? We are taking secondly BD as diameter. If BD is diameter, this angle is 90, this angle is 90 simply. So in short, we can say that. So hence we can say that hence ABCD is a cyclic quadrilateral. Cyclic quadrilateral, right? So to prove any quadrilateral is cyclic, we just prove that opposite angle sum is 180. We done, right? So this is the converse part of the previous part that we have discussed. If the quadrilateral is cyclic, then its opposite angle sum is 180. If opposite angle sum is 180, then it is cyclic. Simple. Both are converse are true to each other. All right. So I hope you have done. Please take a note this one. So let me clear this screen. Moving on to the next question. Now, guys, we have a poll question. It's quiz time. Get ready for the poll question. The first poll question here: 5 points lie on a circle. How many cyclic quadrilateral can be drawn using these 5 points? Anybody? Anybody? Correct. So that we have a 5 cyclic coital we will form, right? Okay, 5 we will form. How we will form 5? I will let you know. Suppose, let's see if I have a cyclic quadrilateral. Yeah, we have a circle firstly, right? And let's draw coordinate 5 points. Sorry, we have 5 points now. So let's say anywhere A, B, C, D, and E. Okay, we have 5 points. Let's join one by one. Let's try to draw quadrilateral. So let's name them. What is the name of this quadrilateral? This is AECADC. ये क्या? AEDC. First one, right? I'm using now the different colors. Now let's see AD, AB, this one, red one. Okay, this is red one. So that's name ABCD. This is one of the quadrilateral cyclic, which is right. Similarly, you will draw one more quadrilateral. I will give you few more. I will not draw all, but try to help you to draw, right? This green one, this one green, like you can see here. So this is also means A, B, D, E, right? Similarly, you will draw by two more angles by your own, right? So in short, we got a 5 cyclic quadrilateral. By changing the different colors, you will just draw and try to do. I'm giving you homework, this one. Do this activity by do it yourself, DIY part, right? Do it yourself. Others two quadrilaterals. So this is quite interesting question, because this question is not in NCERT textbook, right? Now, this is one more poll question we have. Can anybody give me the answer? Value of BDC we have to find. That means BDC, that means we have to find this one, right? It's little bit typical, but let me help you how to find. So if you can see this arc BC, right? By this BC arc, the angle at the center, oh no, look at this angle, and little bit of problem you may face. Okay, so let me help you how to solve this question. See, this is 130. So what is the measurement of this one? This is 230. Yes or no? Yes or no? Yes or no? So by this arc, angle at the center is this one. By the same arc, angle at the circumference is this one. Yes or no? Direction is very important. Direction is very important, right? Yes or no? Are you getting my point? So this angle is 230. How this is 230? Because this is 130. This we got 230 because angles at a point is 360, right? This is 230. By this arc is BC. By the same arc, this we have a angle at the circumference. What is the measurement of this one? This is half of this 230. That is, what is that? 115. Yes or no? 115. And this angle is also 115 because they are in the same segment, है ना? These are in the same segment. Let me clear this drawing and I will show you. This angle and this angle are in the same segment by this arc. So this is 230, right? And we know that this is half of, means this angle is half of the central angle. Don't make it half for this one. Usually people make errors here, right? So this is 115. If you will directly make it half now, you will get 65. And now your answer is wrong. Okay, so please keep in mind direction of the angles, that is very important. As I told, if angle is like this way, then angle must be this way. Okay, if I talk about this angle, then it is 65. I'm not saying this angle right now because this is 130, this is 65. By this arc, simply you can say, है ना, BC arc. So I hope you understood this question. Let's come up with the next question now. So these are the answer. Five quadrilateral we got, and this is answer is 115, right? This is the quite important question and quite toughest question for the today's session, right? Please focus in the question. We have to prove that coital form, if possible, maybe sometime not formed. So if possible, by the internal angle bisector of any coital is cyclic. That means that we are getting this quadrilateral is cyclic, right? This quadrilateral is cyclic. So let me finish in short. Let me, I've just hint you how to solve because we don't have sufficient time. Okay. So let's take, because AH or BF is bisector of angle A and B. So let's take this is X, this is also X, this is Y, this is also Y, and this is W, and this I'm taking Z. Okay, because they are angle bisector which we have given, angle bisector, right? So what is the measurement of this one? What is the measurement of this one? This is simply 180 minus X plus Y. Angle sum property, this angle, right? Means we just add them and subtract to get this angle. Similarly, this angle, this is 180 minus W plus Z, this angle. And this angle, like I'm talking about, AEB is equals to 180 minus X plus Y, and angle DGC is equals to 180 minus W plus Z. Okay. And we know that also this angle in the coital EFGH, they are vertically opposite. That means AEB is equals to angle FEH, and this is equals to angle FGH, right? They are vertically opposite. They are vertically opposite, right? Okay. So basically, we have to check that. We have to check that their sum is 180 or not. Nothing else. So let's check angle FEH plus angle FGH. So that is 180 minus X plus Y plus 180 minus X plus Y. So this is 180 plus 180, 360. Now, if you will add them all X, Y, no, this is Z and W. I'm making it incorrect. Just give me a minute. This is W and Z, sorry. This is W plus Z, right? So now X plus Y plus Z plus W, right? 360 minus, what is the measurement of X plus W plus Z plus X, Y, Z, W, right? So here we have in this coital ABCD, right? 2X plus 2Y, because we are taking XX now, the 2X means angle A, 2Y matlab angle B, 2Z matlab angle C, and 2W matlab angle D. And this is what? 360 angle sum of all, means angle sum of quadrilateral, that is 360, right? So this is to take common, X plus Y plus Z plus W is coming 360. So finally X plus Y plus Z plus W is coming 180 by dividing this two. That means X plus Y plus W is 180, right? So finally we get 180. That means opposite angle sum is 180, right? This one and this one. That means this is cyclic quadrilateral. Yes or no? So this is cyclic quadrilateral we have done, and please do more practice for this question at home. You will get, and this is the common doubts you have, which coital is not always cyclic. Basically, I can see that except rectangle and square, other coital may or may not be cyclic, right? As we already discussed here. So is there any doubts you have? I hope there is no doubts. So let's bind up this session over here. We have done with the whole part of the session, right? Thank you so much for attending today's session. I hope you enjoy it, right? Chalo, bye bye everyone. Let's meet in the next session.